in sections 7.2 and 7.3. Okay, and so first of all, we need to learn about area. And so specifically what we're talking about is what you have in this diagram here. We're going to find that area between those two curves. And up until this point, you had been able to find area, but your area had been of certain like objects. Okay, and they had been concrete objects. And in this case, to find the area of this, you could have used like the geometry formulas that we have. Okay, and so instead what we're going to do is we're going to learn how you can use calculus techniques to find the area of the region between two curves. And so if you look at this, this is a prime example of what we're going to be doing. This first picture is what you saw on the previous slide. Okay, we're wanting to find the area between A and B of this region between the curve of F and the curve of G. So how we're going to do that is we're going to take the area of the region under F. Remember, how can we find the area of a region? What calculus technique? What calculus technique allows us to find the area under a curve?
Yeah, that hard
How we've forgotten. What finds the slope of a curve at a specific
Tangent
point?
line.
That is
Derivative.
the derivative. So what finds the area
Integral.
under integral? There you go.
Guys,
So basically, we can integrate between A and B, the curve of F. That'll give me my area under F. I'm going to integrate A to B under G, and that'll give me the area under G. If I subtract those two, take this region minus this region, you have the region in the middle. Okay, so that's what we're going to be looking at doing. So let's go ahead and look at the next slide that you have. It says if F and G are continuous on AB, and G of X is less than or equal to F of X. Okay, so that means G is under. Like in that diagram, we had F above, G below. For all X in AB, then the area of the region bounded by the graphs of F and G and the vertical lines X equals A and X equals B is given by. So basically what this is saying is, whatever function is on the top, or the biggest, that's what you're going to have here first. Then you're going to subtract whatever function is on the bottom. Okay. And so, notice the first example says find the area of the region bounded by the graphs of y equals x squared plus 2, y equals negative x equals 0, and x equals 1. So first things first, we know we're integrating from 0 to 1. Now what we have to do is we have to find out what graph is above the other. So you're going to have to graph both of those graphs in the same window. Okay, so let's go ahead and graph y equals, in y1, let's graph x squared plus 2. And then let's go ahead and graph negative x. Now we're looking specifically from 0 to 1. Okay, so from 0 to 1, x equals 0 to 1, which graph is above the other? The first one, which is x squared plus 2, right? So what I'm going to do is I'm going to take x squared plus 2, that's my first quantity, and I'm going to subtract from that the second graph, which is negative x. So then now I need to simplify before I can integrate. So notice you've got two negatives which make a positive. So you have x squared plus 2 plus x and dx. So now what I'm going to go ahead and do is integrate. What is x squared? The integral? Okay, x cubed over 3. What's the integral of 2? 2x, okay, there we go. What's the integral of x? X squared over 2. And so then what I'm going to do is I'm going to evaluate those values from 1 to 0. Now, first of all, if you plug in 0, you already know what you're going to get from that one, right? You're going to get 0. So let's go ahead and find out what happens when I plug in 1. So when I plug in 1, I get 1 cubed over 3, which is 1/3. 2 times 1, which is 2, and then 1/2. And then notice it says minus 0. Okay, so if you add all those up, you should get 2 and what? 5/6. Nice job. Okay, so 2 and 5/6. Or that will be 17/6 if you want to answer it as an improper fraction. So the biggest thing you're going to need to find is what curve is above the other. Okay? Now, there will be some times in which they don't give you the limits of integration, and we'll talk about that as well.
It's like an easier way to do the lower sum at the same time.
What?
It's like an easier way to do the lower sum, upper sum at the same time.
Kind of, but I mean, anything we integrated was that. Oops, I hit the wrong way, sorry. Okay, so let's go and look at this one. Find the area of the region bounded by the graphs of f of x equals 2 minus x squared and g of x equals x. So this is a prime example of what I said, they don't give you limits of integration. So we need to find out what the limits of integration are. Okay, so very first thing you're going to start is by graphing. That is step number 1. So if I graph that, 2 minus x squared, that is actually a what? Parabola that opens down. High point is at 2, and it goes through the x-axis at what values? I don't think so.
Somewhere between 1 and 2.
It's at, yeah, somewhere between 1 and 2. It's about like 1 point. It's the square root of 2, which is actually 1.4. So it's somewhere like right here. So there's what your parabola looks like. Let's look at the next one. Okay, x, what is x going to be? Straight line that goes through 0, 0, 1, 1, negative 1, 1. So what they want to know is they want you to find the area between those two graphs. So essentially what I'm concerned about is I'm concerned about this area right here. So what I need to do in order to integrate that is I need to find where are these points right here. What are these x values right here? Okay. Actually, this is what you're going to need to do. We're going to use the intersect feature on your calculator. And so in order to do that, I need you to go to the Calc menu, which is the second and then the trace button. Notice it's in blue. You're going to scroll down to number 5 where it says to intersect. Okay. Now, you're going to hit enter. Now, it's going to ask you for the first curve. So you're going to use your left and right arrow keys to get as close to that leftmost intersection point. Okay, when you get to that, hit enter. Now it's going to ask you for the second curve. So I just hit enter again. And then guess, whenever we see guess, what do we hit? Enter. So where's the intersection at? Negative 2. So now you're going to do the same thing. So go through second, calculate, go to intersect on your calculator, and now we're going to go to the second curve.
Okay, so we're doing that again?
Because you have to get the top value.
1, 1.
And 1, 1. So that top value is actually 1. So my two intersection points are at negative 2 and positive 1. So those are going to be my limits of integration. Now I've got to figure out which one is above the other one. So what will be my first term in the integral? 2 minus x squared. Okay? And then what am I going to do? Minus x. Okay? So then now we just need to go through the process of integration again. Now in this case, I can just jump right to the integral. What's the integral of 2? 2x minus x cubed over 3 minus x squared over 2, and I'm going to evaluate that from 1 to negative 2. So now we need to plug in 1 first of all. If I plug in 1, I'm going to get 2 minus 1/3 minus 1/2. And then remember you subtract what happens when you plug negative 2 in. Okay, so negative 4 minus negative 8/3 minus 2. Okay, why is it a negative? Because negative 2 cubed would be negative 2, negative 3, negative 2, which is negative 8.
How do you know to do the 2 minus x squared first?
Because
the
that-
line goes away from
This is what's on top right here. It's whatever one is above the other. you're looking at this specific area right here. So 2 minus 1/3 minus 1/2 gives you 1 5/6. 1 and 1/6, so 7/6 minus, what's that going to give you? -6, -10/3? It's -10/3. Okay, so add those two together.
9 halves.
Okay. Or 4.5. Okay. So, are you understanding the area? We're going to look at one more then for today's lesson. And this one says find the area of the region between the graphs f of x equals 3x cubed minus x squared minus 10x and g of x equals -x squared plus 2x. So once again, biggest thing you need to start with is graphing.
Oh, there's going to be 2. It's not that hard.
Okay,
We're just going to have 2 integration points.
it's a good observation.
And it's going to be at -1 and 0 for the first one.
Mm. What's going to end up happening is you're going to get something like this. So, what's going to need to be done is we're going to need to find this point and this point for one integration rule, or one integration problem. Then we're going to need to find this point, which we should already have, and this point. So you have 2 areas, and the reason why you can't combine them all on one is because the graphs flip-flop. Okay, one graph is above the other for the first one, and then the second one it switches. So, do we already have the limits for the first one here in the light blue? What? You said -2 and 0? Did you check those?
Yeah, I understand.
Okay, so basically then I end up having 3x cubed minus x squared minus 10x minus -x squared plus 2x dx. And I'm going to add to that the integral in green. And where will the green be from? So the integral will be from 0 to 2 on this one, and that one will actually be the reverse. -x squared plus 2x minus 3x cubed minus x squared minus 10x. Okay, so it's a long integral that we need to go through and solve. Okay, so the first one,
Cancel out the x squared.
the first one does cancel out the x squareds, you're right.
Subtract double x, couple x's from 10x. That would be 2.
So basically what ends up happening is you end up having the integral from, and I'm going to write it up here just because I'm running out of room. Understand I went backwards though. 3x cubed minus 12x. -3x cubed. No, -3x cubed plus 12x.
I really wish we could cancel those out.
Can't do it, sorry. So now let's integrate. Here we get 3x to the 4th over 4 minus 6x squared. You're going to evaluate that 0 to -2. Here you're going to evaluate -3x to the 4th over 4 plus 6x squared. You're going to get 2 to 0. Okay, so let's go ahead and figure out when we plug in 0. You get 0. Oh. Let's try pen first. You get 0 minus. Should be positive 12. Minus 24. So your answer should be 12. Okay. Your next one, when you plug in the 2, you should get negative 12 plus 24 minus 0. So answer is 24.
So do we get to do like units squared or something?
Hmm?
What area? Or units squared?
You could, it doesn't matter. I'm not going to be that particular. Okay, so that's how you find the area of the region under the curves. Now, eventually, what we're going to do, okay, in section 7.2 is we're going to now take that area and we're going to revolve it around the x-axis. So we're going to create something three-dimensional. And so you're actually going to be finding the volume of these solids as we revolve those around.
So we're moving
Okay.
into like application then?
So now, page 452, what I need you to do is 1 through 6, 17 through 20, 65 and 66. I would expect a quiz tomorrow first thing.
Just on this stuff?
Just on this stuff.
Yeah.